Well, I don't know exactly why the little picture of me is a circle, but that's pretty cool. I'll take it. I've never seen the circle before. So welcome from my frigid classroom. I am wearing my coat because it's really cold in here this afternoon. And we are going to do Unit 6, Lesson 3, which is more exponential equations, this time with logarithms. So I've mentioned in class, this is my favorite unit in Algebra 2 to teach. I just think it's an interesting unit to go through. So without further ado, let's get into the lesson material. It kind of bothers me that I'm a little off center though. Quick, move over here. Okay. It bothers me. Okay, so I want to start off with this, and when you take a look at your notes, there'll be a spot for you to write this down. But we have this equation, 8 to the x minus 4 equals 6.3. So if you're doing this from home, what I want you to do is take about 3 to 5 minutes, pause the video, and consider this problem. Just I want you to think about it. You have not at this point been taught how to do this particular kind of problem, okay? So I want you to think about it, because not being taught it and being totally helpless with no ideas or nothing you can try, okay, those are not the same thing. Without using Google or PhotoMath, how could you figure out the solution to this equation using the knowledge you currently have? What are the things that you could do? You have some tools. Hopefully you remember what a solution is. So you're looking for the value of x that's going to do something. What could you do? Okay, now it might be a great idea. It might not be the greatest idea, but it's something you could do. Take a moment and use Desmos or a calculator to arrive at an answer or an approximate answer. Like I think the answer is close to 10. Okay, it's not close to 10, but something like that. So I think the answer will be this or close to this, and you've got a strategy in mind. Okay, now there will be a bonus opportunity tied to this at the end of the class and at the end of the video, but if you don't engage with it now, you're not going to be able to give a good enough response to get any kind of bonus points that are worth anything. Okay, so pause the video, 3 to 5 minutes, just play with this equation and think of something you could do. Okay, and then unpause the video and we'll proceed on with the lesson. Right, so in class, we're going to start off with a class discussion. So consider the equation 3 to the x equals 10. What do we know about x just by looking at this equation? What do we know about the value of x? So I want you to think about this. If you are doing this from home, I know it's kind of two things that are similar back to back, but pause the video if you need to and just think about, like, what do I know about x? Like, I know some things about x. And then I'll kind of recap what usually happens in the class discussion when we go over this. All right, so typically when I do this in class, it takes a little while for a class to get warmed up with what do I know about x? Because even though you haven't been taught how to solve this kind of equation yet, there are some things that you know. You're not helpless in the knowledge base that you have. So I'll often have students start off with something like this. They will say, well, I know that x is not 1, okay? For example, so they might say, I know x is not 1 because 3 to the first power is 3, and that's not 10. So I know x is not 1. And then somebody will piggyback on that. They'll be like, well, I know x is not 2 because 3 to the second power is 9, and 9 is not 10. But when that happens, usually somebody will kind of think, oh, but 9 is close to 10. And so somebody might say, well, I know x is greater than 2. Okay, so then we kind of home in on stuff. So we start off with something that seems very obvious, and then we get a little bit more specific. X has to be greater than 2. And then somebody might say, well, x is not, like they might say, not a whole number. Okay, so maybe somebody goes up to like 3 to the third and they're like, ooh, 3 to the third is 27. That's too high. And then eventually, usually what will happen in a class is we'll settle on this. We'll settle on x is between 2 and 3. And so we end up there. And then sometimes I'll kind of poke a class a little bit further. I'll kind of like poke and nudge you a little bit further. And I'll say, okay, is it closer to 2 or is it closer to 3? And then students have to think about that for a little bit. Okay, is it closer to 2 or is closer to 3? Well, 3 squared gives me 9. We're looking at 3 to the x, and 3 to the third is 27. And so once we start looking at that, a student might say, well, I think x is going to be closer to 2. And the reason for that is because 10 is closer to 9 than it is to 27. So then I'll get like a little bit, we'll talk about it a bit more, like, do you know how close it's going to be? And then we get like a little bit, well, I'm not sure. But the point of this whole exercise is to really, first of all, get a sense of what it is we're trying to find. So we're trying to find the value of x, but also to emphasize that you are not helpless when it comes to figuring out problems that you haven't been taught how to solve yet. There's actually quite a few things that you know about the value of x, even if you don't know exactly what those algebraic steps are to figure out what x is. And that's why we always read every question. We don't write something off just because it looks unfamiliar. Okay, so if this were a multiple choice question and you had some numbers that were greater than 3, you're not going to pick numbers that are greater than 3. You're going to pick something that's between 2 and 3. And if you have options between, something that's closer to 3 or something that's closer to 2, you're going to pick the one that's closer to 2. Now, if you have 2 options that are closer to 2, now you're probably going to have to guess. But there's a lot of power in being able to think about a problem and think about what you know about a possible solution, even without going through the algebra. Now, we do run into a bit of a roadblock here. So we're at this point kind of stuck with maybe trial and erroring our way. Like you could try 2.1 or 2.2 and then maybe 2.15 or 2. However this is going to roll out. And that's not very efficient. So that brings us to this. We need another method for solving exponential equations. We cannot just raise everything or write everything as power of the same base. And we can't necessarily trial and error our way. Now we can, when we have access to Desmos, try to graph it, okay? And we have explored some solutions like that, and that's absolutely fair game for this. But algebraically, if we don't have access to Desmos, we need some kind of method for being able to do this. So that brings us to our star of the day, introducing something called a logarithm. Okay, great math word, L-O-G-A-R-I-T-H-M, logarithm, and it is abbreviated log, L-O-G. And so you might have heard me say earlier this year, I love doing exponentials and logs. Okay, and when I say logs, that's short for logarithms. Okay, so we will talk about, like, I am studying log. If you're going to meet with a tutor, you're going to go, I don't know, your grandma asks you, what are you doing in math class? I don't know, maybe that's just like my family where we ask those questions. But you say, we are studying logs. You would not have to say logarithms, but it is short. Now, what is a log? There's a lot of ways we can define this, okay? But one of the common ways is to introduce it in that concept of inverses. And so we studied inverses just before the break this year, and we know inverses are functions that undo each other. So you've got like adding and subtracting are inverse operations, and multiplying and dividing, squaring and square rooting. Okay, and so we add to that this pair of exponents and logarithms. So if you have your variable stuck in an exponent and you need to undo that in order to figure out what the variable is equal to, then a logarithm will be the tool that you use to do it. So here we've got some breaks. A logarithm undoes an exponential. Okay, and we defined that last lesson. An exponential is some kind of equation where the variable is up in the exponent. And how does it undo it? It does it by changing the form. So this is a little bit crowded on my PowerPoint there. So it does it by changing the form. So this is a key idea. This is one of those those grounding principles. I am not going to just launch you into steps how to solve an equation without making sure that we ground those steps in some truths. Now, there are some activities that you can do to explore this, to try to find the equivalent forms, but we will pass on that for now. So here's what we've got. We have b to the x is equal to n. That's the exponential form. And then we will write this as log base b of n is equal to x. Now, I don't have a copy of the notes in front of me because at the time I'm recording this, it's actually in the copy room. So hopefully we'll have that by the time we do this in class. But I do want to emphasize how we say this out loud, because a lot of times I'll hear students just kind of whip through this. So on the left, the way we would say that is b to the x equals n. Okay, that's how you would say it. So you don't say bx, you say b to the x is equal to n. On the right-hand side, I will often have students say log bn. Okay, that is not specific enough. So if you notice this right here is what's called a subscript. Now, we've seen that in the formula for slope. You've seen subscripts before. Sub means lower. Think submarine is lower, under the water. Okay. And script is writing. So subscript is the opposite of a superscript. Subscript is written smaller and just below the line or level of our normal writing. So you do need to make sure that this is a subscript, just like the exponent is a superscript. And the way I would read that on the right-hand side is this, log, and then I would actually say the word base. And then I would say what the base is. So in this case, the base is b. And then I would say of n equals x. And so this is actually an operation that you would do on a number. It's kind of like a square root. So you would take the log of n. And which log are you going to take? You're going to take log base b of n. So you're going to do something to that n. Now, when I was in school, I was probably maybe the last year or two that they would have dragged you through this process called interpolating a logarithm, which was awful, and it involved calculations and doing stuff on a table. Nowadays, if we want to find the value of a logarithm, we just do it on a calculator. So we just dump it in and we get a decimal to carry out what that process is. So the left-hand side, b to the x equals n. Right-hand side, log base b of n equals x. And so when you are reading these out loud, if you're reading them to me or to a tutor, or just we're talking in class, we do want to say it correctly. We do not say log bn. The b is the base of the log, and the n is something called the argument of the log. It's what you're going to operate on. Now, this particular formula will be on your reference sheet, so you don't need to have it memorized. It's on your reference sheet for your EOC. However, if you don't have it memorized, especially in the short term, it's going to take you a lot of time to keep looking it up over and over and over again. So it's one of those things that's probably worth trying to commit to memory, okay? So make sure that you're writing this down. This is not something you want to skip. Pause the video if you need to. All right, so our first skill today is just going to be changing the form. So if you look at these three examples, they are all written in exponential form. 3 to the x equals 10. 2 to the 3z. Why did I do that? 3z. Why do I have a feeling that should have been an x? Plus 1 is equal to 20. And now I'm thinking probably on your notes it says x. But 2 to the 3z plus 1 equals 20, and 5 to the 2n. And then do take a moment and notice this. Here you've got the plus 1, and it's up in the exponent, but here the minus 3 is clearly bigger, and it's written on the same level and size as the 5. So this 3 is not a part of the exponent. This plus 1 over here is. It does matter. You cannot be super, super messy when you write this, because you have to be able to tell what's in the exponent and what's not in the exponent. So for the third one, that's 5 to the 2n, and then you're minusing the 3 equals 18. So all we are going to do in this particular skill is rewrite that exponential as a logarithm. So I have 3 to the x equals 10. The base is 3. The base of the exponential is going to become the base of the logarithm. So I'm going to start off with log, and then I want the base of the logarithm. Well, the base of the logarithm is whatever the same number as the base of the exponential, which in this case is 3. Of whatever that number is off to the side by itself, 10, and that is going to be equal to, in this case, x. And so that's all we're doing at this point. We're just taking something that is written as an exponential and we're writing it as a log. In other words, we're writing it with the inverse. You've actually done this before. So if you have ever taken something that was like 10 to the 10 minus 6, and you rewrote it as 10 plus negative 6, that's taking subtraction and writing it as the inverse. You're writing it as the inverse operation, which would be addition. Now, you don't just change a minus sign to a plus sign. You have to go ahead and change other pieces of it as well in order to make sure that you're keeping the same expression. But it's the same idea. You're taking something that's written as an exponential and you're rewriting it in its logarithm form. These are actually the same equation, just written 2 different ways. What's really important about it is that this x that was previously trapped inside the exponent is no longer in the exponent. Okay, and that's the key thing, because remember, we're trying to figure out what x is. So for the next one, it's done the same way. We start out with log, and then the base of the exponential, which in this case is a 2, will become the base of the logarithm. So this would be log base 2 of 20. So we pull that number from the other side. And then the key thing is that the variable is now out of the exponent. So this has got a more complicated exponent. It's 3z plus 1, but that whole exponent is just going to come down and become the right side of the equation. Remember, math is consistent. Okay, so just because the exponent is yuckier doesn't mean that the rules change. Now, on this last one, we have a little bit of an issue because our formula is for like b to the x equals n. I think that's how I had it written. There's no room for like a minus 3. So you could say, well, log base 5 of 18 equals 2n, but then like, what did you do with the 3? I mean, the 3 is there. So before we can change the form over, we do need to make sure that we get it so that it matches our key idea. And the way we would do that is we got to move that 3. That 3 cannot be there. So in this example, we would start by adding the 3 to both sides first, which we can do because it's not part of the exponent. And that'll give us 5 to the 2n equals 21. And now we have it in a form where we can change it over. So we would have log. Remember, the base of the exponent will be the base of the logarithm. So this will be log base 5 of 21 is equal to 2n. Now, this is what I call skill 1. It is just practicing changing the form. It is a low-level skill, meaning this does not involve critical thinking. It's just rearranging stuff, and you just got to make sure the parts get in the right spot. But it's a very easy skill to mess up, and it's an easy skill to forget if you don't practice it enough. So let's just come on over to the next slide. Take a moment, pause the video. Okay, and rewrite these in your notebook or on your note sheet or whatever you got that you're taking notes on, and then unpause the video, and then I'll go over them so that you can check and make sure that you're doing them correctly. Okay, so the first one doesn't actually have any variables in it, which is fine. It's just 7 squared equals 49. And so this would come out as log base 7 of 49 is equal to 2. If you say so, Ms. Taylor, log base 7 of 49. The next one would be log base 8 of 20 is equal to 3p. And if you're not paying attention to how I'm saying it out loud, do. Okay, we want to say this correctly. Now, this last one is like the last one on the previous slide, where you do need to deal with that plus 2, because that plus 2 is not part of the exponent. And so we need to subtract 2 from both sides to get 6 to the x equals 10. And now I have something in a form that I can change over. So we would have log base 6 of 10 is equal to x. So hopefully you got those correct, but if you did not, this is a risk-free time to get stuff wrong. Pause the video, take a moment, make a couple corrections if you need to make corrections, but also pay attention to like, what was my misconception that I got those things wrong. All right, now this doesn't really help us if we don't know what to do with the log. So it's like, great, log base 6 of 10. What is that? How am I supposed to even know what that is? Now, this is where we are going to get into a little bit of a battle between what used to be a really important skill and what is not necessarily important anymore because of the way technology has evolved. But there's like a little blurb about this on a future slide. So suppose you have log base b of some number a. Now I like using b because b is basement. Okay, that's the base of the log. It is the subscript. And then a is the argument of the log. So we have b and a, and we have some great vocab there. So we have the base of the log and we have the argument of the log. When you're going to change this over, actually I should probably give you a little bit of a history lesson. Back in the day, not that long ago, calculators could not do logs of any old base. They only did 2 kinds of logs. They did something called a common log and something called a natural log. And so a common log is base 10. And if it's base 10, you don't need to write the base. And a natural log is base e, and that actually has its own symbol, and that is a future lesson. And so if you ended up with a problem that was log base 6 of 10, your calculator actually would not do it for you. And so what you would do is you would use this thing called the change of base formula to change your base 6 log over into something that your calculator could do. And the way I remember this is I say this is the log of the attic divided by the log of the basement. And so kind of look at this visually here. So the B is in the bottom, it's in the basement, and it stays in the basement. And your argument or your attic is up high, and it's going to stay up high. Now, what that is, it's actually log base 10 of A and log base 10 of B, but we don't need to write the 10. And that actually changes it over into a log that your calculator is able to do. Now, where this is becoming an outdated skill is that most new calculators actually will do logs of any base. And so it's becoming an outdated skill where you would need to rewrite your logarithm, but it is a specific standard or benchmark on your exam. And so we can't just jump over it and not cover it. So I do have to cover it for you. And then you're going to use Desmos to evaluate. Now, remember the word evaluate means find the numerical value of. So evaluate is whenever you're just going to deal with just numbers and figure out what all those numbers are equal to. So you're going to add them, subtract them, substitute them. In this case, you're going to evaluate the log, and you're going to figure out what it's equal to. Okay, so what we're going to do here is the change of base formula, and I'm going to show you a couple things to kind of get to where we want to go. So so we have a log base 3 of 10. So I've got the base of 3, that's like my basement number, my bottom number, and then I have log 10. And so what I'm going to do is do the log of the attic, okay, or that top number over the log of the basement. Now, what I want here is I want to figure out what that is equal to, and I probably should have, I just wrote it so it's gonna crowd out the problem next to it. So this was what? Log of the attic divided by the log of the basement. Okay, and so I'm going to come down here to Desmos, and what we're going to do is just type it into the window here. We're just going to get what it's equal to. You're like, well, now there's a couple ways you can do that. I believe you can just type in log, okay, and you'll notice that the font kind of changed, and so I can type in log 3, okay, and it'll give it to me, or you can open up the menu. I'll show you both ways to do it. So if I want to do log 10 divided by log 3, I am thinking I'm going to need to put the top one in parentheses. Otherwise, it will not do it right for me. Divided by log 3, and I get that number right there, 2.0959, so forth. Just for, well, let me write that in there. So 2.0959. And you might be wondering, well, what should I round off to? Typically I go 4 decimal places, but you will see some like teachers or lessons that will go like 3 decimal places. Usually not 2 though. Usually we want a little bit more accuracy than that. Just for fun, I am going to learn something right now. If I do not put the parentheses around it, and I just do log 10, and then I hit, oh, it did work. Well, there you go. Okay. So you don't need to put the parentheses. I thought it might change the argument to 10 over 3, so we won't want to do that. Okay, so there you go. So the next one, so we'll come over here and do the next one here. So this would be log of the attic number divided by the log of the basement number. And then you will need to use a calculator. You are not going to do this without a calculator. I think this might let me just edit the numbers so I can put in the 2 and put in the 5. And I get 0.4306. Now, if I look at that next digit over, that next digit over is a 7, which means it is going to round up. Rounding is problematic for a lot of students. And a lot of times I think students don't want to say anything about it because you're like, oh, I should know how to round. But I know a lot of students really struggle with what those rules are. So if you need a refresher on rounding, please speak up and let me know. You're not going to surprise me. I'm not going to think any less of you, I promise. Just I know that's one of those things we have to go over. So the last one is log base 7 of 49. And if you want to go back in the video a little bit, you'll see that this should be equal to 2. Okay, so this should be equal to 2. And so let's see if it is. So we're going to do the log of the attic or upstairs number divided by the log of the basement. And then I'll come over here. And I think, yeah, I can delete the whole thing, or I can hop in and do 49 and edit that. And oh, wow, look, it's a 2. Awesome. Now, this is a skill that you do need to know. That change of base formula is a specific benchmark this year that we do need to cover. And so you could see questions that are like, here's log base 7 of 49. And then there's 4 answer choices that are using the change of base formula that you would then need to pick the one that was equivalent. Now you can always just dump them into Desmos. But I do want to show you over here on Desmos that if you open up this, well, maybe it won't. Maybe I won't show you. Nope. I will see if I can show you, or I'll record a separate video that just kind of goes through how we can do that in Desmos. But there is, if you go into that functions menu and you scroll down, you will see log base something, and it'll open up a logarithm where you can type in the base. So if you're doing this, I'll try to record that video as soon as I'm done with this one, so that you can have access to that. So here are a couple to practice with. All right, so pause the video, okay, and do this out on Desmos and get yourself a number, and then unpause the video and we'll come back and go over it. Okay, so let's go through this now. If you saw that, I was actually just grabbing my calculator because I don't have Desmos pulled up for the rest of these, so I'm just gonna have to do this on my calculator. All right, so what do we have going on here? We have this will be log of 81 divided by log 3, which I believe is 4. We got log base 3. I'm actually doing it a different way on my calculator. It is. Okay, and then this one would be log of 4 over log of 6. There's a tendency to always want to make your base the smaller number. And I've done that. That's one of those things that sometimes students will call me out on. And because they'll think, oh, the big number always goes on top. Well, not necessarily. It's the argument versus the base, the attic and the basement. And so it doesn't matter the comparative size there. So this is log base 6 of 4. So we're doing log of 4 over log of 6. And this one would be 0.7737. And what you might notice is whenever the top number is smaller, you end up with a number less than 1. You might notice that. Okay. So as an aside, Desmos will evaluate logs of any base, but this formula is specific for the benchmarks. So feel free to use either for this class, but be sure to practice this formula on at least a few of your problems so that you can get questions that you might see on it. Like I said, it's like a skill that used to be very, very important with calculator usage and is no longer that important. In fact, the calculator that I'm sitting here doing this on, I don't need to use the change of base formula for that. Okay, so let's bring this together to get that process for solving. So you know how I typically do lessons. We start with some key ideas. We start with some key skills, that vocabulary. We want to have all of that in place. And then I'll give you a roadmap for solving a problem. So we'll actually get into that process and some steps. And the idea is that just like when you're driving to a new place, at first you need to follow the map really closely because you've never been there before and you get a one-way street or something. And you have to pay attention to it. But the more times you drive to the same place, the less you need to look at a map until I'm sure there are plenty of places that you go on the regular that you do not have to use a map to get there. Why? Because you've done it enough times. And that's where this map comes in. This is like a map, okay, for when you're first starting out solving the problem so that you know where to begin or what pieces of the problems you want to look at first. But the more problems that you do, you should not need to be looking at this map. It's part of why homework is important. So step number 1 is you're going to isolate the exponential. Okay, we're going to isolate that exponential. Now, in this case, the exponential is that piece right there. It's not the plus 10. The plus 10 is too big and it's written too low. So I want to get that by itself. And looking at this, I need to get that 10 out of there. That 10 is being added, so we will subtract that from both sides and we'll get 4 to the n minus 3 is equal to 5. So we actually did that step earlier. You do want to isolate your exponential first because you need to get it in the right form. Then we are going to change it to a logarithm. Okay, and that goes back to that skill 1, that is just changing this form. As this is written, I can't solve for n. Can't do it, okay, because it's stuck up in that exponent unless I want to play guess and check for a long time, which I don't. So I'm going to change this over, and so that'll be log base 4 of 5 is equal to n minus 3. Now, a couple minutes ago, 20 minutes or so ago, we got stuck here, okay, because we didn't know what to do with that log base 4 of 5. But now we know what to do with it. We can change that base over and we can actually evaluate it. So step 3 is evaluate the log. Now you can do this in 2 steps or you can do it in 1 step. I just do want to make sure that you are at least at times using that change of base formula. So that's going to be that log of the attic divided by the log of the basement. And then we will dump that into our calculator. So we have 5, and that's going to give me 1.1610 is equal to n minus 3. And then my last stop is solve for the variable. So once we get it to here, we should have a linear equation that we can now get the variable by itself. So I don't particularly love that number, 1.1610. And if you are following along, it's like 1.16096, and the 6 rounds the 9 up to a 10, which is how we end up with the 10 at the end. Now, to get the n by itself, I have n minus 3, so I know I can undo subtraction by adding. So I'm going to go ahead and add 3 to both sides. And I absolutely would use a calculator for this, okay? Because while adding isn't usually an issue, subtracting definitely is. And there are times, especially when you have some negative numbers in there, students will be like, oh, I can totally do this in my head, and they'll do it backwards. So please use a calculator. Okay, so there are your steps. Step 1, 2, 3, and 4. Isolate the exponential, change it over to a logarithm, evaluate the logarithm. That means get that decimal number that goes with it, and then you should be able to solve whatever is left. It'll probably be a 1 or a 2-step equation at that point. Okay, now I did color code this, so you got some nice colors, so you can match up the step on the left with what it looks like on the right, and that's your roadmap. So that's where you go back when you're starting to do these problems out. Like, okay, where do I look first? Okay. So we have a couple of additional examples just to see a few other things. So the first example here, I think, is just walking you through that roadmap again. So step number 1, isolate the exponential. In this case, the exponential is already isolated. So 5 to the 3p equals 15. So that's all good. Step number 2, change it over to a logarithm because that p is stuck up in the exponent. I don't want it there. And so I need to get it out. And the way I do that is by writing this as a logarithm. So log base 5 of 15 is equal to 3p. And now that p is outside of the exponent, which means I have all of my tools for linear equations at my disposal here. Now I'm going to grab my calculator, and you can do this in 1 step or you can do it in 2. Okay, my calculator, I've actually been doing it in 1 step because my calculator will do log base 5. But if you don't want to, or you have a calculator that doesn't, you're going to do the log of the attic divided by the log of the basement. And you should be able to dump that in. And I get 1.6826 is equal to 3p. And then step 3 or 4 is solve for the variable. So that's 3 times p. I'm going to divide both sides by 3. And hopefully you just kind of keep that number on your calculator. So well, you can't see it, but I've got it sitting on my calculator. So I'm just going to hit answer divided by 3. And I get 0.5609. That's 609. That was messy. Let's see if I can do that 6 a little bit better. 5609. There we go. And there's my solution. Now, this last example here, oh, and always, as always, you pause the video somewhere if I kind of zoomed through a piece of this lesson a little bit fast. So this one I want to do because we typically run into an awful order of operations problem where people will be like, oh, I will do 2 times 4 and I'll get 8. but you need to remember your order of operations on this. It's not, you don't do multiplication before you do the exponent. So it's only the 4 that is being raised to the, I should be pointing at it. It's only the 4 that is being raised to the 2x minus 1, not the 2. So if you multiply those together and you get 8, now you've got to merge those together and you're actually raising the 2 to that power as well. So that would be the wrong thing to do. But what we do want to note here is that that is multiplication, and I can deal with that too, not by multiplying it, but by dividing both sides by 2. Okay, and then what happens here is 2 divided by 2 is 1. And then we end up with 4 to the 2x minus 1 is equal to 3. Okay, step 2, change it over to a log. So this would be log base 4 of 3 is equal to 2x minus 1. And then this would be the log of the attic divided by the log of the basement. You do not have to do that step if you want to use Desmos to do it, but or a calculator that does it. So log base, oh, I did that backwards. Log base 4 of 3. So that is 0.79 25. And then my last step is to solve. So I want to solve for x, so I need to add 1 to both sides. And I'm going to run out of space on this, so I'm going to move up to like a little bit further up here. 1.792. That is not going to work, is it? I don't know. I guess I'll go up here. 1.7925 is equal to 2x. And then divide both sides by 2. So add 1, divide by 2, and I have 0.8962. 8962 is equal to x. Sorry, I ran out of space. Even when you run out of space, though, we'll turn this into a teachable moment. Even when you run out of space, your work should still go top to bottom and then left to right. So if you need to use more space, try to move in a reasonable way. So we're going to do top to bottom, and then I'm going to move left to right. So I'm going to move over to the right, and then I'm going to continue with that top to bottom as much as I can. So I apologize, that's not the greatest layout here. All right, I need to leave work. Okay, so that brings us to our practice problems. Now these are to be done on a separate paper and turned in. So you have 3 to the x equals 10. So we kind of started the class looking at that problem. We have a 4.5. Don't let that throw you. Everything is the same because math is consistent. It's really great. To the x plus 2 minus 3. The minus 3 is not part of the exponent. Okay, you can tell because of the size that it's written at, equals 10. And then we have the problem from the very, very beginning of this lesson. 8 to the x minus 4 is equal to 6.3. And at the beginning of the lesson, I asked you to try to think of some ways or some tools, some things that you had at your disposal for coming up with an answer to that. Here's your bonus opportunity. After you solve all those, I want you to compare your thoughts at the beginning of class on number 3 with what you know now. Okay, now specifically, because that's kind of broad, can the methods you described earlier verify the solution you now have? So I want you to think, how close did you come to the right answer? Did you come really close? Did you not come close? Can the methods that you described, would they get you to this answer? Did they get you reasonably close? Maybe if you spent time on it. Up to 3 bonus points depending on the depth and quality of your reflections. So if you really didn't think of it earlier, you can't answer that question well now because now you have too much knowledge to be able to answer it. So I really wanted you to think about that at the beginning of class. How successful was it? How close did you come to the right answer? Okay, so even if you're doing this from home, you know that this is an assignment. You can get this turned in. You can snag that bonus opportunity. Typically, if you're absent, I'll excuse you from the classwork, but this has got a nice bonus opportunity, so hopefully you will take advantage of it. All right, as always, I know this is a little bit longer video, but it did cover a lot of material, and hopefully these equations feel pretty good for you. But you know where to find me if you have questions, and I will see you next time.